This video is going to cover the topic of substituting variables in algebraic expressions. Be sure the date and topic are at the top of your page. The essential question that should also be on your page is, how do we substitute variables in algebraic expressions? When we work with expressions, we see variables that represent unknown values. For example, the expression 4g plus 7 means that there's 4 of some value, maybe grapes, right? 4 baskets of grapes. We don't know how many grapes are in each basket, plus a constant of 7. That variable could mean anything. Maybe it means 5, maybe it means 10. It could be anything, and depending on the value, the total of this expression would change. When we substitute variables, we need to take the value provided and replace the variable with the letter. And then, of course, when you've done that, you would solve normally as we do with PEMDAS, order of operations, snow cones, however you want to call it. So with our example 4g plus 7, perhaps g equals 5. We would need to replace our g with 5. And of course, we need to remember that 4 is the coefficient, so this means it's multiplying this value by 4. So we can write 4 times our 5 plus 7 to continue on with our order of operations, which of course means that we would get 20 plus 7, which would give us a total of 27. What you don't want to do would be to say 4g plus 7 and make it look like it's the number 45, right? That is not what we want to see. And of course, the result would change if the value of g changed. So if we were told that in 4g plus 7, we wanted to figure out what it would be if g was 10, we would just replace that with a 10 and continue on to get our final answer of 47. The result changed because the value of g changed. After all, the value of a variable can vary, right? That's the key word, variable. It can change, and the result of your substitution changes depending on the value of the variable. We're going to look at another example, but we've been working with the distributive property and combining like terms, and so I'm going to show you how that can impact how you substitute your variable. So I have two places set up here to solve or evaluate 5 times the quantity of y minus 6 plus 10, and we are given that the value of y is 2. So the first thing we can do, that I'm going to do here on the left-hand side, is go ahead and replace the y with 2. And then I can work my way through order of operations, right? I can say this is negative 4 times 5 plus 10, then I would multiply negative 20 plus 10, and then of course I would get my final value of negative 10. On the other side, we can distribute the 5 first. So I can say that it's 5 and then parentheses 2 minus 6 as we did before, but I could distribute this 5 out to my parentheses. So I could get 10 here, and then I could get minus 30, and of course outside the parentheses we still have our plus 10. And when I go through my order of operations, I still end up with negative 20 plus 10, and so I still end up with negative 10. So there are a couple ways you can approach this, and I'm going to show you a couple more variations with a different example on how to substitute as well. So again, I've set up two sides here to kind of show the different ways we can do this. But on both sides, I have 3b plus 10 minus 4b, and we know that b is equal to 3, so we want to evaluate, substitute, and figure out what the value would be when b is 3. So one way to do this is to substitute right away. So we have 3 times 3 plus our 10 minus 4 times 3. And from there, we can just go ahead and snow cone and do order of operations. And if b was equal to 3, if we evaluated this expression, we'd end up with a value of 7. We can also, however, combine our like terms first. I'm going to do that on the right-hand side. So if I look at this, right, we've been practicing this, we know that we could say, well, I have 3 b's, and then I also have negative 4 b's. So before I do anything else, I could combine that and say I have negative 1 b, right? A 3 and a negative 4 would make negative 1, plus our 10. And then I can substitute in my 3. So negative 1 times 3 plus 10. And I would just do my snow cone as I've done. And you'll get, of course, the same result of 7. It just looks a little bit different if you combined first. And some people prefer that. They might find that more efficient. Sometimes it's better that way than others, right? So you kind of want to be flexible in your thinking and use that when it's more valuable to you. So here's another one, 10c plus 9 minus 2 times the quantity of 2c minus 8. And we know that c is the value 2. So I want you to pause the video and decide how you want to substitute 2 for the values for the letter c, and then we'll see how you did. And I'm going to show that there is, of course, more than one way to do this, so choose a way that you think works for you, and then I'll show you perhaps the other way that you didn't have. How'd you do? So I decided to actually distribute first. So I did my negative 2 times my 2c and got negative 4c, and my negative 2 times my negative 8 and got a positive 16. Once I distributed, you can see I have my color coding here. I combined my like terms so that I had my c's together and I had my constants together. And it was after all that I replaced the c with 2, which meant I really didn't have too much calculation to do with the actual numbers themselves. So I have my work here on the right-hand side. I want to make sure that you have your work here on the left-hand side. And if you did it in a different way, we want to see if we got the same thing. So I'll take a look at it and see what strategy you used when I take a look at your video in class. And I'll leave you with one more for you to complete before class. And I'll check your answers as I check homework. So we have 8 times the quantity of 2h minus 5, and then all of that plus another 4h. And h is going to be the value 3. So where you see h, you're going to be using the value 3. And you can distribute first, you can combine first, you can just plug it in and solve with PEMDAS, right, with your snow cone, order of operations. But think of a strategy that's going to work for you, and then show all your steps so I can see what process you used. Be careful with your work, and either way, follow all the mathematical rules that we have been practicing, learning and practicing in class. And remember, the essential question of the video was, how do we substitute variables in algebraic expressions? And of course, we really just plug it in where we see our letter, but then we have some choices of how we want to proceed after that. And we're just going to make sure we have some time to practice the different ways to do that.